Hi, this is homework 10 and question 1. It said from the lecture notes on the definition of simple property of the example of stochastic process. So first is the push process. So first one, is like the number and t1, t2 of the points in an interval t1, t2 whose length is t. The probability of this t1, t2 equal t is e to the power of minus theta t times theta t to the power k divided k factorial. And here the xt equal to the n to the 0 to the t, and the mean is e to the xt, and theta t. The autocorrelation is r t1 t2 theta square t1 t2 plus the minimum of t1 t2. The auto covariance is c t1 t2 is theta mean of the t1 t2, and the second is the Poisson increment. At the process of yt is x here, the t plus minus xt and divided, and the probability of the masses is p of yt n to the e equal to the e to the theta e. Now this one mean here. The autocorrelation r t1 t2 have two conditions. When the absolute value is bigger or equal it or less it, and the autocovariance is c to the also the absolute value is bigger or equal than a small one. And the third one is a point as a point impulse is to the zt, the derivative of xt by the t, and the mean is e to the zt is it. Autocorrelation is here, covariance here. The fourth one is semi-random telegraph signal. Is from here to here. The masses p is from here, and the autocorrelation is right here, and fifth is right here, and 6 and 7 is also the random telegraph signal, the random walk in the wind process. So for the first one, I think the mean of the Poisson process of theta t, which is the linear function of t, and then the matches our common sense is the longer time we wait for the expected number of buses is like larger. The autocorrelation function contains a term of a mean of a t1, t2, which come from the property of independence increment. And for the second one, the Poisson increment process is introduced to prepare us to define the Poisson impulse process. And it's interesting to see that an expression of autocorrelation from here, this part, and the triangle area is theta with independent on the c. And then it goes to 0, the triangle becomes an impulse with the area of theta. On the third one, I think the persons here, zt, has 0 mean, and autocorrelation is right here. That is, it is probably white noises. In the real world, there are some shot noises. That is a figure on the like this. And the fourth one, if the pxy is not 1/2, because we probably start at +1, and it shouldn't be a little higher than 1/2. Yeah. And fifth one, I think right here. So from here to the 1/2, this makes us guess like it may be a strict sense stationary, and yt is constant probably, and also make a guess it's a strict sense stationary. And then the sixth one, from the probability methods, we guess probably that when n goes to infinity, we will have the Gaussian density. The autocorrelation function contains term of mean of t1, t2, which come from the property of independent increments. And the last one, I think interesting to see it's already here. Well, thank you.